Welcome to the Trend Detection Podcast powered by Siemens. And now your host, Niall Sullivan.
Hello, good afternoon or good morning, wherever you are in the world. I know it's morning where my guest today, David, is. Welcome to this episode of Trend Detection Live. Really excited to have one of my American colleagues on today, David Peterson. And we're talking today about how to leverage existing data for predictive maintenance, which I know David's recently done a presentation with a mining sort of group, and I won't sort of go into David's background. I'll let him introduce himself, but he's done a really interesting presentation recently about that. So I thought that was worth exploring further, and maybe I'm opening up to a wider audience too. So without further ado, actually, before I always forget this, but we do have a comments feature, so a chat feature. So if you do have any questions at any point, please put them in the chat, and I'll feed them back to David as we go. We won't do a Q&A or anything like that at the end. We'll just feed them as we go. So without further ado, I'll pass over to David just to introduce himself. David.
Thank you, Niall. It's good to be here. Thanks for inviting me. I'm David Peterson. I'm a mechanical engineer. I have a background in the last 30 years of heavy equipment, primarily with groups such as he mentioned, mining and metals, as well as aerospace. I've spent a number of years overseas, so I do speak, read, and write Japanese. So I kind of brought in a little bit of everything together in this predictive maintenance field, and I'm currently here in the Rocky Mountains.
Awesome. You can't quite see it, but there is a lovely view behind David, who showed me just before. It is a lovely view. But we're not here to talk about the mountains behind you, David. We're here to talk about data, which I know is something we talk a lot about on the podcast and at Senseye as a whole, because we know how important it is, or we know how important it is. But I guess my first question is actually how, from your point of view, how important is data to a successful predictive maintenance project? Because you're right there in the woods and
it's absolutely vital. Yeah, honestly, it's absolutely vital. You can't do predictive maintenance without having good quality data. But I want to point out that you actually need the right type of data. We like to bring in data from different sources, such as condition monitoring. I want the sensors from the machine. I want the features that come off the machines. I also want operational data. Like, for instance, if you change product lines or something of that nature, I want to know about that. In addition to that, to run a predictive maintenance deployment, we've absolutely got to have some sort of maintenance data and feedback in terms of what is relevant and what isn't.
And in terms, I mean, that's a lot of different data sources. I mean, generally, do you when you talk to a new, say, prospect or customer, do you find that they have that data readily available, or is it a case of bits of some and not a lot of the other kind of thing?
Right. Well, more recently than in times past, there's kind of a mad rush to get in on the digital transformation bandwagon. So customers have a lot of data. That doesn't mean that they necessarily know what it does or why it's important. If I was to give a guess, I'd say 80% of the data that is available isn't looked at. And even if it is looked at, they don't really know how to use that to their advantage in many cases.
I mean, that's definitely what I've seen. I think I've mentioned it on a few episodes at events. I was at an event in Munich earlier this year, and I had that exact speaking to people. It's amazing how, we've got data here, over here, in all these different systems, but we just don't know how to bring it together to derive value. So I think you're right. There's been a shift, and I guess it's to do with Industry 4.0, or a lot of it's down to that. And I guess people or companies starting to embrace that technology. But what sort of role does that Industry 4.0 play in sort of data collection and that side of things?
Oh, that's a great question. As I said, there's a mad rush to get on the board. Everyone feels like they're going to be left behind. Initially, the Industry 4.0 was about improving processes, quality, things of that nature. But increasingly, we're seeing more of that in terms of it's helping people be more efficient, meaning they're saving money. And so there's kind of been a shift in what Industry 4.0 represents to companies. One of the other factors is sometimes a company will rush out and they'll buy all sorts of sensors. They want to produce data, but they don't really understand. They need to clearly define what the problem areas are, where are their areas of concern, and how is technology going to help you address those problems in those areas specifically. And so I think that Industry 4.0 plays a significant role in terms of helping people identify where the bottlenecks are, where the problem areas are, because many times we've learned how to adapt to problems, and we don't really view them as problems as much as we used to.
So how often so I mean, how often, within an organization, in terms of sort of data collection, I guess what we're talking about here a lot is data being in siloed, because you talked about before about all those different types of data, but in some ways they represent different areas of the business. So how hard is it to bring those data sources together? Because I guess it's like it's a company culture thing as much as a data, integrating data sources thing.
Absolutely. What we find is that a lot of people have data silos, and that can be either organizationally caused, or it could be technically defined. In other words, we may have some older machines that are producing data that goes into a SCADA or SCADA, depending on where you're from. Goes into a SCADA scenario. Some will go into PLCs. We have edge devices that are working on an entirely different network. And so data silos becomes a very real challenge where it's hard to identify where a problem is if you can't actually see it, or you can't actually gain access to the information. So that is an absolute problem with the modern technology, trying to mesh the various technologies together. And it could be anything from a customer historian, or maybe they have a cloud storage system. We look at their and have their storage systems, or maybe their CMMSs, wherever the information is coming from. To remove those barriers is one of the things that we really try to focus on.
And I guess in general, let's say a tool like Senseye, is it able to work off a small amount of data, or is there a lot of work required to, say, fill in some of those architectural gaps, let's say, like installing sensors and SCADA systems and things like that?
Okay. Yeah, we take a different approach than many others competitors in the space. We like to use data as it becomes available. I don't necessarily have to have a long history of data. I don't have to go out and spend 8 or 9 months having data scientists create specific models, primarily because the models aren't all that accurate in a lot of situations. For instance, you mentioned that I just addressed a mining company or a mining organization. Let's say you have 2 identical machines, completely identical, maybe a vertical shaft impact crusher. One of them is bringing in 2-inch minus rock. One of them is bringing in 3-inch minus stock as well. One of them is producing something that is very high in, say, maybe a kaolin clay, and it's soft. Another one might have 50% plus silica content that's very abrasive. So those exact same machines are producing very different results, and they're producing very different maintenance needs. And so to go spend 9 months and a lot of money to create a model for that type of an application just doesn't make sense. So what we like to do is we bring the data in from the sensors as it happens. In fact, all I need is between 2 to 5 days per regime in order to create a good baseline working model from a machine state, constant machine state, and I can detect deviations from that point forward. So a lot of that information, a lot of the data that we collect is specific to not only to the asset and to what the machine is, but also to the specifics of the use case that machine is working in.
Absolutely. And a lot of what we've spoken about to this point is about companies that have data and are collecting data, but there's obviously still companies out there who may not necessarily be starting on that journey. So, I guess we've talked a little bit about it, but what are the benefits of using existing data versus starting completely from scratch? And how would you start? What would you recommend? I was just going to say, and also sort of second part is, if you are starting from scratch, how would you get started? What's the recommended? Is there a recommended sort of process to go through to start collecting data?
I think there's a lot more data out there than people realize. Most of your OEM equipment comes with some type of data, whether that's temperature, pressure, torque, sometimes even vibration. A lot of data is already onboarded onto the OEM equipment. it's just simply a matter of understanding what's available there. If you can extract the data and understand what's going on with the particular asset without having to add additional data sensing devices, then you've come out way far ahead. I mean, we've seen companies go out there and spend between $200,000 and $500,000 just on adding, say, vibration sensors, when they could solve a problem just on using a pressure differential. Case in point, like for instance, we might have regenerative thermal oxidizer, RTO, and it brings in all the toxic gases. It throws it through a media bed, and it comes out. So if the media bed becomes plugged up, or it starts getting plugged up, we need to understand that becomes a problem. It could become a safety issue as well. You don't want to have any fugitive emissions sending particulate out into the air. But if they come with pressure differentials, or the pressure sensors, pressure in, pressure out, I can immediately start sensing if there's a degradation in the media bed. I don't need to have any type of vibration analysis per se. I can, but if I can find out the health of the machine without adding additional cost to the structure, then that makes a lot of economic sense to us. So yeah, I guess you could say you want to use existing data. You want to leverage that, and there are hundreds of different use cases or thousands of different use cases where you can point out you already have enough existing data. For the second question, those that don't have much data or many sensors at all, talk to us. We send out engineers to on site. We do an audit. For instance, I was at a steel mill last week, and before that, I was at a tire manufacturer, and the week before that, I was at a car manufacturing facility. What I do is I'll do an audit and try to find out what the problems are, what data is available, and how we can leverage that data to move forward. If they don't have it, then I give them some examples of ideas of, hey, you might want to look at this type of a sensor located at this area on the particular asset. And we basically take their hand and walk them through the process of upgrading or modernizing their fleet.
And that's a good thing to sort of dive into a little bit, actually. So in terms of selecting the asset, it's based on a number of factors. Maybe you could go into, I know it's a bit wider than the data question, but how we'd go about identifying the assets to at least start a project with or focus a project on.
Okay. Well, first we need to identify what is an asset. Some people may think of an asset as a large machine. Some people may think of it as a small component. We tend to take it down to the basic unit that can be measured. So for instance, as an example, some people say, hey, an ID fan is an asset. Well, an ID fan is composed of a screen, it's composed of a motor, it's composed of the fan itself, composed of a gearbox. And if there's a problem that arises, I want to have my people know exactly what's the problem. Is it a gearbox issue? Is it a bearing issue? Is it a motor issue? And so we talk about assets as being the lowest common denominator of what composes a machine. So first I have to identify what an asset is, and then I need to identify the failure modes. How should this be behaving, and why does it fail? For instance, let's say I have a pump or a motor. Let's talk about a motor. You have a drive end on the bearing and you have a non-drive end. How does it fail? Does it fail according to misalignment? Is there a problem with uneven loads? Any number of different components become involved with understanding how does this asset fail and what does it look like before it fails. Then I want to understand, okay, well, if data is coming off these sensors, what data tags are available? Can I get pressure information? Can I get temperature? Can I get emissivity? Can I get torque? Can I get vibration? A huge list. And my recommendation would depend on what is the application. If this is an underwater pump, it might be a lot different than if it was simply a pump a pump that's in, say, an RTO or something of that nature. There are times when we'll actually do offline data analysis to assist in the data story. What is that machine actually telling us? We'll do that as well. So to be honest, we prefer data that indicates how healthy a machine actually is, as opposed to not all data is created equal. We want to make sure that we're getting the right data and that it is applicable to running a successful PDM program. Does that make sense? I hope that answered your question.
No, it definitely did. It definitely did. And again, I think it comes back to what we were saying before about maybe some companies over or underestimating the quality of the data. And actually, there's stuff in there there's some nuggets in there that are actually quite useful. But from what you're saying is sometimes it just requires a little bit more of an in-depth sort of, like you said, offline analysis to
Right.
identify that.
And that's what we do, Niall. We sit down with the engineers and we talk about, okay, what is the problem? We sit down with the maintenance team. What are you seeing? Tell us about what you're experiencing. Where are your problem children? What's going on? And to be honest, most companies tend to overestimate the quality of their data. But the reality is that most data that's being generated is focused on production visibility. People want to know how many units are being made, how many times was this machine stopped, what was the duration of the downtime. Whereas I actually want to focus on what the machine health is, the condition monitoring. So we help them understand the difference of the quality of data, as well as how much data is too much. Is it possible to have too much data? Yeah, I don't want the raw data. I want to extract features from that. I don't want high frequency raw data. I don't need a data point every half second. I want to see a min, max, and mean, say maybe every 5 minutes, or maybe every minute, or maybe every 10 minutes, depending on the application. So to your point, understanding what data is available and what data would work best for the particular type of predictive maintenance you want to do on which asset, that's where our experts work with your team to help identify very clearly what works and what is, quite frankly, a waste of money. You don't want to waste money by throwing it away after something that yields no results. Our team helps you identify that exactly.
So it's condition monitoring experts would be the people to identify, to look at that data in more at that granular level. No, that's interesting. I mean, is there a reason why companies overestimate the quality of their data? Is it just a lack of, I don't know, education? Or, I mean, it's still maybe now that companies collecting data is now is a thing to be done, but maybe the next stage is that educational bit about what data, like you just listed there, the data that's required. Is it sort of an educational gap that's missing at the minute?
Perhaps. I think it is a perception issue. People see data and they think that it's pretty much equivalent, which it might work for one situation and not work for another. And I think that one of the reasons why they overestimate the quality is simply because they just don't know better. No judgment. I'm just here to help them understand where it's going to be helpful and where it isn't.
Exactly. I mean, to be fair, with all the different sources and and requirements, I'm not an expert, obviously, but I can see where it can get complicated. Because I guess Industry 4.0 is all about collecting data, connecting your systems, and collecting that data. But then when you do it, it's like, oh no, that's not the right data. It can be a bit of a minefield, especially when you've got obviously lots of other priorities, to contend with as well.
Yep. Multiple sources. You have an IoT enabled device or a sensor. Maybe you have a gateway, some sort of an IPC. You have edge processing, factory historians, the CMMS, the EAMs. You have a wide range of communication protocols. Even let's say an open API. There have been times where we have some customers that are very remote and they don't have a network available. I've even taken emails for a CSV file every day. Just email me the file. Just give me the data and I'll figure out how to take care of it. But there are so many complexities to it that that's really why the experts are there. That's what we do. We help simplify and streamline all of those different data sources into a single usable stream of data. And that's really what we do. So from sensor to Senseye is where the art comes in.
Yeah. With that sort of insight, you should be in marketing with that kind of line, that summary. But fortunately, we're recording, so we can we can say I can save that one for later. So what I wanted to move on now is, and obviously you were just saying in the last few weeks you've travelled to different sites, but in terms of a successful example of a deployment with using existing data, which I think we do have a really good example, which I know you're going to talk to us about. So yeah, if you could take us through that'd be really interesting.
Okay, I can give it to you two examples. One is a large international aluminum mining company. 2018, we brought on about 50 different assets. Their goal was to see if Senseye would work. Now, to be fair, back in 2018, a lot of companies were trying to prove the concept. At this point, it's a proven concept. There's no real question on whether or not it works. We have large multinational corporations, a lot of them that are using our data. It's a proven concept. What isn't proven is, can we use your particular data to do well? So they brought on about 50 assets in 2018. We did a full investigation process. We sent engineers to Iceland to look at their infrastructure. We found out that the infrastructure is very well done. Currently, we have over 1,000 assets online that we're monitoring automatically. We have plans to be expanding that. And this is all through COVID, we began to expand from 50 to over 1,000. A second example would be in an automotive manufacturer where we began in 2016. This company had spent about a year looking at all the available options for AI, ML companies to do their PDM program. They were looking to reduce their unplanned downtime by about 50% year over year. And in the automotive sector, that's very expensive downtime. You're talking anywhere from hundreds of thousands to upwards to millions of dollars per hour of downtime. So they really had to get a handle on that. Well, we started off with only 30 assets. They say, okay, let's go ahead and try this. So after a year, they selected us, and we moved forward in 2016. By the beginning of within 3 months, we had already blown that number out of the water. The reduced unplanned downtime by 50%. We'd already blown that out of the water. We currently are in 9 of their factories with over 11,000 assets that we're monitoring. And the very cool part about that is the original team of 3 of the maintenance team professionals that joined us when we started this project back in 2016, they haven't had to expand. They haven't had to hire any additional people to implement this. That's what our software does, is it actually helps you understand exactly the health of the machine without having to add data scientists or reliability engineers, things of that nature. No, that's what we do. So there's another success case where, so one of those visits that I had last week was to bring on some additional factories from that same company.
Two really interesting, I guess, and diverse use cases there. Just on the point of not needing a large team, or to, let's say, scale the team when you scale to, as you scale assets and deploy more assets. I mean, maybe you could dive in a little bit in terms of the scalability factor. And if we want to twist it back towards the data sort of slant on it, how does having data affect, scalability possibilities? Let's say how quickly you can scale. How does having existing useful data help or hinder that?
I guess the best way to answer that would be to say, once you have the ability to onboard existing data sets from regular running baseline conditions of any machine, whether it's, like I said, a 30-year-old machine or a new edge device that came on 2 weeks ago, we can identify a baseline figure of that within a very short period of time, just a couple of days. Once that's been done, and I can begin monitoring that and determining any type of deviation from the norm, then I'll say simple, but it's not. It's a simplistic approach. It's very easy to scale over tens, hundreds, thousands of assets in a fairly short amount of time. It's not unusual to bring on hundreds of assets in just a couple of weeks. Instead of going from years, talk about weeks and months rather than years and multiple years. But it's simplistic, but it requires work on everyone's part. This isn't a magic box where you just simply plug in data and everything pops out for you. It takes a little bit of upfront effort to understand how to onboard it. And that's what our people do, is we actually help the prospects, help the customers figure out what is worthwhile to monitor. Can you expect the most ROI on bringing on a PDM program? And we also we'd help them to identify what their goals are. If the goal is to reduce spares or to reduce unplanned downtime or to increase availability, all of those they have a slight nuance that's a little different. And we try to help them understand how to leverage the data to achieve whatever goal they're getting at, and that does include a little bit of effort.
No, absolutely, and that's why we have things like Omniverse and our knowledge platform to help, to help with that kind of thing as well.
Glad you brought that up. Omniverse, for those who don't know, Omniverse is a knowledge database. It's a knowledge sharing component that we use. So if we bring on someone new who wants to participate with the PDM program, we have a knowledge base that teaches people how to use data, how to bring it on, how to onboard assets in a quick manner that is easily scalable. And that's just part of our system. So yeah, the other thing that we also see is there within Omniverse, we actually have a sharing platform where maybe you have multiple locations or multiple factories around the world. So not only internally, but you can actually share solutions for how you solved a particular problem.
Oh, so it's like the community aspect, really. It's, because everyone has different experiences, different points of view, and they can add into the conversation, I guess. So everyone's sort of continuously learning from each other. Is that a fair way to summarize?
Absolutely. One of the things that we noticed was that with when the pandemic hit, you had a lot of people taking early retirement. You lost a lot of very knowledgeable staff, and it's hard to get people coming back into maintenance. And so when a new person comes on board, we don't want to just dump them out into the factory without any support. And so a lot of what we do with both Omniverse and inside the program, when we have alarms, we call them cases. Some people call them alerts or alarms. When those come up and we send out someone, we tell them where the problem is, what are the likely contributors to it, and how to possibly address fixing that. We actually help create a living document that is a database of how it would help a newbie understand how to do their job most efficiently. We draw human attention to the assets and the areas precisely to where it's needed most. Yeah, and that's all through data.
No. Yeah, and it's all automated, I guess, as well. That's the beauty of it, I guess. Sorry. Sorry, David.
Oh no, I say some of our customers will come in, and the first thing they do is they'll sit down and they'll go through reams of data. They'll spend hours and hours trying to understand what the data is saying. Whereas what we'll do is we'll actually take that information and automatically direct their attention to the areas that need their attention. There's no sense in looking at data if the machine is perfectly healthy. We direct the human attention exactly to where it's needed.
Yeah, which I think we can all understand when you're monitoring thousands of assets. That's quite important. Yeah, because it's about potentially smaller maintenance teams having to deal with more assets. So a tool that can point out the ones that require immediate attention is always going to, it's obvious really when you put it like that. But what I wanted to ask you, David, is we talked a lot about the project and importance of data, but which stakeholders would you say need to be involved in that process, both on the data side, and you mentioned earlier about bringing in maintenance people as well, but are there other stakeholders needed to ensure the success of or potential success of the project?
Sure. First thing is we like to make sure that someone has a vested interest in making this succeed. We like to call them a champion. Someone who's there, someone from our customer who says, you know what, this is my project. I'm going to make it work. So that may be from any of the available departments, but we like to see someone from maintenance involved. We like to see the reliability engineers involved, if you have them. If not, we figure out how to get there. Data scientists, if they are there. You have some customers will have PDM teams. So we work very closely with the PDM teams to magnify their efforts in a substantial way. We like to see the maintenance planner, if you happen to have one, help them understand how to manage projects, especially if maybe you have one maintenance planner, but you have 3 different locations that are very remotely separated from each other. So we like to make sure that the maintenance planner is also very heavily involved with understanding how to understand the program, how to direct maintenance efforts.
And that's interesting because there's quite a diverse sort of list of like different departments. We talked a little bit earlier about cross-departmental sort of collaboration. Is there, I mean, culture we talk about a lot at Senseye as well, about the importance of having the right culture for these projects. It's not just about the technology. Do you see, let's say, I don't know, like disagreements, I guess, in terms of approach from the different departments? Because they all want the same goal, no doubt, but they're sort of all coming from different angles, if you understand what I mean.
Absolutely. Absolutely. A lot of what we see is you have people who want to do things the old way. Let's just go ahead and over-maintain this by doing a ton of PMs. You have people who want to embrace new technology, but they don't really know what direction to go. You have others who are very well versed in what predictive maintenance is and the methods to use and the tools that are at their disposal. To get cross-departmental collaboration is a very helpful thing. And I had a thought that I completely forgot what it was I was going to say with that. Let me see if I can recollect what I was going to mention that, because it was very relevant to your point.
That's okay. Well,
I will move on and see if there's anything.
No, that's okay. I mean, we talked about departmental, cross-departmental, but I think something we also see as well from your experience is, it's a plant-by-plant collaboration as well, because, some big global customers with plants around the world, essentially, I guess, if they're not connected in terms of asset, say, visibility, then potentially a lot of that information can be lost as well.
Absolutely. And that's another component that we want to bring out, is that visibility across not only departments, but across locations and across the entire corporate structure that ability exists, depending on what the customer wants to see or who's going to be involved. This is primarily the system that we have is primarily designed for the maintenance professional. But we also have corporate types who want to understand what's the relative health of my factories around the world. Maybe they have to do costing structures or things of that nature. We have all sorts of KPIs and other reports that are available to them across the board, across different factories, across different departments that are automatically generated for them, making their job a lot easier.
And how challenging can it be? Because each plant can sometimes be, it's almost like their own business. So they have their own, I guess, their own way of working, their own culture in some ways. But also on a data collection level, in terms of IT infrastructure, they all might use different SCADA systems, different data historians. I mean, how do you overcome some of those challenges where,
yes,
even though they're within the same company, but actually, in a lot of ways, they're very much separated from each other in terms of their approach, let's say.
Yep. They are. And depending on when they either acquired or built the factories, they may have different legacy systems that they're using or things of that nature. I did want to point out that in terms of data, we are data agnostic. And that means that I can use any historian, I can take any sensor and process that information. So it can even be my competitor who's developed a sensor that I can use. That's fine. I can use the data off there. I can use any historian, any CMMS, even internal CMMSs. In terms of data, I want to be data agnostic. I want to be able to use any data from any source and display it on any type of device. So whether that's a computer or a tablet or a laptop or even a phone. So in terms of data availability, bigger is better.
Absolutely. And actually, a way to extend that point is this fits into maybe the collaboration aspect as well, but it's also about fitting into existing workflows. Again, I was talking at an event last week to a prospect, or let's say prospect who was at an event, but that's what they were very keen to know, whether, can you fit within our existing workflows? You're not going to try and introduce a new tool and sort of everything changes. It's about whether it's, pushing data to a Power BI or a Tableau, using brands. That's all right to use, I think, but we get the idea, those type of tools. Right. But how important is that in your view as well? It's fitting within existing structures, let's say.
Well, not to talk in cliche, but people don't like change. They want to make sure that their existing systems that work well for them are being utilized by a new tool. So we want to make sure that whatever tool is being developed is going to be fit perfectly into their flow. We don't want to be disrupting anything in terms of how the processes are supposed to work. We're supposed to be helping people, not hindering them, right? So we want to make sure that that we fit within their existing systems. Sorry about that. Go on.
No. It seemed like you might have remembered your point from earlier. I thought it looked like a light bulb moment there, but
it was, but that's okay. I'll wait for the next question.
No, that's all right. No, I'd say come back to it. Let's go back to it. It was an interesting discussion point.
Well, this kind of goes back to when you talk about this is kind of the nexus between several different points that we've already discussed. One is the siloing of data and the siloing of departments one from another, or it could be factories one from another. You maybe have multiple locations, and that's a problem that some of these large corporations, all large corporations, deal with. The other thing that I wanted to point out is the loss of information is in itself as a data. It's a silo. So when we have these people that are retiring, it's hard to get quality people in. One of the most common things we hear is it's hard to get quality people attracted to these jobs. So if you talk to any HR expert, and they'll tell you that it's difficult to get a quality maintenance professional coming in. And one of the things that we've noticed is the younger generation, they don't view maintenance as a sexy job. It's just not sexy. It's not something attractive to them. But then you tell them, oh, by the way, you get to work with AI, ML every day. And suddenly you start getting people, oh, you know what? I changed my mind. I'd actually take a look at that job. And so we're finding that customers are telling us that they're getting much more interest in jobs, people applying for jobs just because they get to work with advanced technology. That really is a big draw to the younger generation to bring in new talent. So when you talk about removing data silos, a human can be one of those data silos that we want to make sure that we're integrating quickly into the system.
Yeah, that's a really good point. A really nice way, because that's one thing I really, slightly biased working for Senseye, but one thing I really find interesting about the system, because AI, you could very easily get wrapped up in AI and machine learning, how exciting it is. Maybe it's a great way to attract talent. You're absolutely correct. But for our system, the human or the maintenance insight, the person who knows the asset, the person who sees the asset and knows what work's been carried out on the asset, etc., their feedback is just as important. Maybe you could discuss how that works within a Senseye context. So I think that's always an interesting point.
Okay, sure. Anytime you're looking at AI, ML as a way to do predictive maintenance, you want to make sure that the data is good. You want to make sure that the data is relevant. So if I happen to have maybe I have just a regular planned downtime, and suddenly my sensors are reading a bunch of zeros. Well, zeros going into an AI component isn't very helpful. So fine, we'll have the human put in, hey, here's some planned downtime, or here was some unplanned downtime, or something of that nature. If they begin recording, then it begins to strengthen the algorithm substantially. In addition to that, the human understanding what's going on in terms of regime, we call it regime, maybe different products. So for instance, you may have the same robot in an automobile manufacturer that, for 2 or 3 days, it's picking up this size motor to put it, or drivetrain to put into the chassis. Then the rest of the week, they're picking up something that's half the size and putting it over there. Well, those are two very separate, different data requirements or maintenance requirements or demands on the system. So depending on which particular regime or product mix I'm happening to be using at the time, I want to understand what is the baseline behavior for that robot with this particular product that it's using. And so we have some of our customers are using maybe a dozen different regimes, and they can program their or they can understand, have their attention directed to a problem as it develops according to each individual regime that it's working on. So a human needs to understand how to input that with and we help people understand that as well.
No, very interesting.
So, and then of course, feedback. Yeah, feedback is also important. So, for instance, if I have a bearing that's creating noise, everyone's trying to move towards this dark factory where you just have one person monitoring the whole factory. You have people in there. So if a bearing happens to be screeching because it's short on grease, there's no one in there to hear it, or it might be in a noisy environment and they don't hear it. But the AI ML program, the predictive maintenance algorithm, will automatically find that. Oh, we're increasing our torque, or we have a problem with vibration, or we have a problem with the temperature, maybe of the non-drive end bearing. And so what it does is it automatically brings it to the maintenance professional's attention, and it tells them what to do. And so when they go out, they'll spend maybe 2 hours. Go out and they'll look at it. They'll determine there's a problem. They'll put maybe 3 or 4 units of grease in there, come back and enter the information in. Hey, we took care of this. This is what took place. What we also want them to find out is, okay, well, wait a second. What if the bearing had failed? It would have destroyed the bearing, but it may have destroyed the bearing housing as well. Maybe a shaft would have bent. So how much downtime did I actually avoid? If I had to replace these other items, how much value did this program actually bring to me? Well, it's pretty substantial. You talk about 2-hour downtime to grease something because it was brought to your attention, as opposed to, say, 16-hour downtime.
Yeah, and there's a nice link there. We're actually releasing a report on the true cost of downtime this week, so you can see some of those. I won't reveal anything, but yeah, you're across different industries, the varying costs. It's not just the actual cost of stock production, but there's lots of add-on costs to that. But we're not talking about unplanned, not talking about unplanned downtime specifically today. Maybe for another session. So I see we're sort of coming to the end, but what we usually ask David at the end is always quite useful. Just if you've got any sort of key takeaways, sort of on the subject of leveraging, by the way, that's the topic today, leveraging value from existing data. So just your final thoughts and a summary of what you think is important for everyone to take away on this subject.
Final thoughts. I would say that there's more data available than most people realize. And it doesn't have to be anything fancy. You can get just traditional standard data, your temperature, pressure, torque, amps, things of that nature, things that have been around for decades that have already been included in the OEM. There's so much data that's already there, and that most people ignore that, and they think they need additional sensors or a lot of different new machines. Leverage what you have. Put your money where it's actually going to yield a high ROI right to begin with. There's so much data that's available that people aren't utilizing at all.
Yeah, exactly. I guess just to add to that, I guess it is easy to be drawn in by all new hardware, all new sensors, and all this new stuff when there could be sort of gold, sitting on top of a pot. Yeah. Sitting on a top pot of gold. I think that's a nice way to summarise and finish. So thank you very much. So that's all for this session, I guess. But it's been really, really interesting subject again. Thank you to David for participating and giving your expert thoughts on this subject. Really good. And thank you everyone for listening, both live and on the recording afterwards. So on that note, enjoy the rest of your day and thank you very much.
Click the link in the description to find out more and to be notified of our next live episode. And to see more about Senseye Predictive Maintenance, go to Siemens.com.